Okay, well, we're going to now look at how to go about measuring the spread of a series of numbers. So this is the second moment. And let me go back to what we did before. I'll just say recall the one of the measures of central tendency is the median. For example, we took the example of the United States. We have 330 million people, let's say. We line them all up from the guy that's living in a van down by the river, and then we go all the way over to Bill Gates or Jeff Bezos or whatever, and then we line them up from the poorest to the richest, and then we walk down the long lineup of these people, and we find the person in the middle. This is the median income. We go up to that person and ask them, well, how much does this person earn, the 165th, whatever it is, and whatever income they tell us, this would be the median income. But what we want to do with the spread is measure how spread out these numbers are. One measure, obviously, the range. We could go to the lowest person, the poorest person, and then go to the highest income, and that would give us a measure of the range. Of course, the median does give a bit of a sense of it too, because we know that half of the population is on one side and half the population on the other side. When we look at the problem with these numbers, and the range in particular, is that it throws away a lot of data. In other words, there's about 329 million something. We haven't taken that into account. So the range is very sensitive to the extreme cases. And statisticians are a bit like economists. They don't like to throw away data. They like to be able to use all of the data, all of the numbers available, so you get a better measure of how spread out these numbers are. For example, a lot of the poor people could be a lot of the people rather than the population could be near the low end, and very few at the top end, and that would give us the range would give us a poor example, because it would imply that the one person is very rich, one person is very poor. We don't really know the spread. As I say, it throws away a lot of data information. So we'd like to have a better measure of this. So take a quick idea of what we mean by the range, the median versus the average, each one. Here, I'll go back to the simple example we had before with just 5 students in a class. And in this case here, we can say that the range is the lowest mark, Albert, is 62. Charlotte, she got the highest mark, that's 95. Sometimes this is reported as the lowest, highest, and sometimes it's just the difference between the two. As you can see, it's 33. Different ways. There's different ways of reporting this concept. In computers, frequently they use the word minimum or maximum. So rather than lowest or highest, same concept. It'll be a function. We'll see this in Excel. There's a function called max and min, which very, very easy way to find out in a long series of numbers which is the highest and which is the lowest. I'll go back to this average thing we had before. We put them on a number line. Recall that the average is kind of the way the fulcrum that will balance out all of these various numbers. Bear in mind too, the median is 68. That's Boris. He's the person in the middle. Whereas the average of the marks we calculated before is 72. So it's the point that measures it. And one of the key points about the average, it really is literally the place that balances it. Recall too that if, for example, I increase the mark of Dilbert, raise it, well then the average will change. But of course the median, Boris 68, will not change. So the average is very sensitive to where all of these numbers are. We're going to use this concept when we look at this idea of how to measure the spread. So what we're looking at really is a variation, or how the numbers are distributed around this mean number. So that gives us an idea of whether the numbers are spread or not. So let's consider a possibility. Let's say we look at the variation of the distance from each person to the mean. So if I do this, I've got this guy here as well, 62, Albert. He's going to be 10 points below the mean. And then Boris is going to be 4 points below the mean, and Charlotte is going to be plus 23. So we're getting a pretty good idea of how far out the numbers are from the mean, whether it's far away or close to the mean. 7 is going to be minus 2, and this one here is minus 7. Now, if you look at this carefully, you add up these numbers, minus 10, minus 4, plus 23, minus 2. You can check this on your own. You get 0. Now, is that because of the numbers I chose? If I chose different numbers, would I get a different result? And the actual fact is no. And another way of looking at the mean is the mean is precisely the place where the deviations, when you add them all together, the variations all add to 0. Of course, the average is going to be 0 here. And you can sort of see our problem. Our problem is that minus there's a -4, a -10, plus, there's the minus and the pluses kind of cancel out. And as a result, we get to 0. So if we could somehow change the minuses so that they're pluses, but then leave the plus as a plus. Now, you may recall from another class in arithmetic, mathematics, there's something called the absolute value. And that's very convenient here, because the absolute value would say, if it's a negative number, make it positive, and if it's a positive, just leave it positive. So let's take a look at this idea here. If I took the absolute value, well, this would become +10, this would be +4, and this would be +23, and this would be +2, and this would be +7. Now, if I add all these numbers together, if I got this right, I get 46. That would be a pretty good way of measuring whether the numbers are spread out or not. Because if they were not spread out at all, it'd be 0, because then everybody would be the same. But the further they get away from the average, in this case 72, the bigger this number is going to be. Well, that'd be a pretty good measure. The first problem, of course, we're going to face is I've only got a class of 5 students here. If I added more students, 6, 7, 8, class with 30 students, 40 students, or whatever, this number is going to get bigger and bigger. Not because the numbers are more spread out, just there's more students in the class. So the first thing I want to do is just take the average of these numbers. So I'm going to call this 9.2. If you take 46 divided by 5, you can check with the calculator, you get 9.2. That would be a better measure of the spread, if you will. This is a great idea. It works. One of the problems is absolute value, these straight lines where you take it's kind of difficult to work with. And so mathematicians, statisticians have kind of found maybe a better way of doing it. Now with computers, of course, it might refer back to this method because it works. But the general way of doing this instead is using a function that achieves the same goal. It makes negative numbers positive, but leaves positive numbers positive. And the way that's done is by taking the square. So that's what I'm going to do next. Rather than take -10 and turn it into +10, I'm going to take -10, and if I square that, as I've seen here, I get +100. And if I square this, I get plus. So you'll notice a negative number becomes positive. A positive number, 23, is going to be +529. And it's going to be +4, and this one is +49. So we've overcome this problem of the canceling out because we got minuses and pluses. And so we've turned the negative numbers into positive numbers. And we've done it like the absolute value, but we're using the square instead. It's a little bit more, the term that's used for this is tractable. So if I look at the total of all these numbers, I think if I get this right, you add them together, you get 698. And this is actually an important number in statistics. It's referred to as the sum of the squared deviations. So you can see it here is the difference between each of the individual numbers minus the average, which is 72 for the entire class. Now, the next step, of course, the problem we're facing is that as we get more and more students in a class, this number is going to get bigger and bigger. So it's not a really good measure of how spread out numbers are. So the next step is to take the average. I've got 5 students. So I take 698 divided by 5, and I would get 390.6. I think that's right. You can use your calculator to check. And this is known as the mean squared deviations, or sometimes it's so well known, it's sometimes known as the sample variance. And you notice I even use a special number or letter here, S. S squared, because I've squared them all, because it's the Latin letter, so it represents the sample. So this is a classic standard measure, usual measure of how spread out numbers are. Keep in mind, the smallest this number could be, well, it would be 0. In fact, let's take a look at that possibility. Imagine, last little point I want to make, the sample standard deviation, of course, we'd want to take the square root. We squared them all, we want to take the square root of that. I'll do that in a second. But let's consider a different class. Imagine I've got a class of 5 students. Once again, class average is going to be 72 because everybody got 72. Well, in this case, you can see quite a bit. Well, in this case, it would be the deviation would be 72 minus 72. I'd have 0 here, 0, 0, 0, 0. The total would be 0. The average of them would be 0. And if I squared them all, it would be the same thing again, 0, 0, 0, 0, and then 0, 0. And This would indicate the total square deviations would be 0, and this would be the sum of this would be divided by 5, which is equal to 0. And the sample deviation would be simply 0. So I want to make 2 points about this idea of variance. The first one is, what is the lowest variance possible? Well, 0. That would mean, like in the class a moment ago, everybody got the same mark. There's no variance at all. Everybody's the mean, so they're not spread out in any way whatsoever. So you can never have a negative variance. That's impossible. Second point I want to make, and you'll notice something here, I changed this to n minus 1. In the previous, what I wrote, when you calculate the average before, I divided by n. But now for the variance, and this is the correct formula for it, is n minus 1. And why is that? Well, I've given you a quiz, a bonus quiz if you want to, because it involves linear algebra to understand why that is. But I give you a simple explanation for it a bit. Is that if, for example, you had a class of one student, let's say the student got 78% in the class. Okay, so that's the average. The median would be 78, the class average would be 78. Well, what's the variance, or what's the spread? What's the range? Well, you can't really talk about that then, because you've only got one student in the class. You can't really say that the minimum, the maximum, it doesn't have any sense. So the point here is that to be able to talk about spread of a series of numbers, and by this I mean the second moment, you must have at least 2 students in the class. So when we divide by n minus 1, it's kind of like the universe saying, if you only have one student in the class, n is equal to 1, you can't do the calculation. You're trying to do something that's impossible. In fact, it'd be like dividing by 0, which, again, some people say, hey, can you do that? It's equal to, no, dividing by 0 just means you can't do it. As they say, the universe is telling you you're trying to do something that can't be done. So that's the first simple answer to this question. The reason we divide by n minus 1 is because you cannot have a variance. You cannot calculate a variance if there's only one student in the class. Another way of looking at it, too, is to simply say that in the process of, and this is kind of closer to the actual reason, is that in the process of calculating a variance, one of the observations gets used up. So as a result, the degrees of, technical term, we'll see this later, but the degrees of freedom in this case are only really 1 in a class of 2 people. And the degrees of freedom are, in this case, are calculated as n minus 1. If it arises during a quiz or a test or something and you're a bit confused about whether you should divide by n or divide by n minus 1, you can raise your hand and I'll come over and explain to you which it is. I want to finish with this little idea of the basic concept of variance. What do we mean by this? And by this, I'm looking at the spread, or what would be in statistics the second moment variable. So we'll consider 3 examples. Let's start with the first example. Let's consider a variable x that represents the daily temperature during a year. Okay, 365 observations, and we'll look at 2 cities, Montreal and Havana in Cuba. So if we look at the average temperature in these 2 cities, on average, where is it going to be hotter? Now, keep in mind, we're looking at the entire year, 365 days. Well, clearly, on average, it's going to be hotter. The average temperature in Havana is going to be greater than in Montreal. Fine. But what about the spread of the temperatures? By this, I mean how the temperatures vary and change. Well, in this case, we would say that the distribution, or the variance, or the standard deviation of the temperatures in Montreal is greater than in Havana. So make this understand clear. The first moment, the average is going to be colder in Montreal, but the spread is greater in Havana. This is the concept. Let's take another example. Look at monthly salaries of different occupations. For example, the salaries of teachers and the salary of real estate agents. On average, it's probably fair to say that teachers earn less than real estate agents. That's probably true. One reason people become real estate agents is they have a fairly high income, on average. But if we were to look at the monthly income, it's probably fair to say that the variance of their salaries is much greater. Teachers, every 2 weeks, the money is deposited in their bank account, so it's very predictable, very understood how much they're going to, they can plan ahead what they're going to earn. In the case of real estate agents, they can go several months where they have 0 income, and then suddenly they have 2 or 3 sales. They do very well. So the variance is going to be much greater for the case of real estate agents than it is for teachers. Probably true for salespeople too. Incidentally, one of the factors when we look at why some professions or occupations have high incomes as opposed to others is this volatility, if you will, or the spread of their incomes. Generally, people don't like to have changes in their incomes. They prefer to have something relatively stable. And so as a result, in order for people to accept to work in an occupation where the salary varies a lot, you kind of on average have to pay them more, even if it means you may go several months without being paid. Let's consider a third possibility. How about this? We've got two professors, Professor A and Professor B. Professor A on average gives higher marks than Professor B. So you might say at first glance, I'll take a class with Professor A because on average the marks are higher. But look at this. The standard deviation of the marks in Professor A's class is greater than Professor B. Well, that means that, yes, on average, Professor A gives out higher marks, but the volatility, the spread of those marks is greater. If you looked at it from that perspective, there may be a chance that, you may fail with Professor A. With Professor B, you have a little bit more certainty of what mark you're going to get. So this is another illustration of the concept of variance.